So a friend of mine sent me some code. Why is not here? Maybe here. So some code that we have two versions of the code. So one of the versions looks like this, with this if statement on. And the other version, it looks like this, with the if statement off. I guess like this. So here we're just trying to test if this number is in the range between minimum and the maximum. So very simple algorithm. And here we have this logic. So if the value is greater than mean and less than max, then we return the value. If it's less than mean, return mean. If it's greater than max, return max. So we are thinking like this algorithm, it does the same thing as this one, and it uses less computer cycles. But is it really true? That's my question. So in order to explore this idea, I'm going to try to rewrite this thing. Let's just write it into C. And let's try this experiment. So here, what I'm going to do is I'm going to change this clamp function to maybe int function. And instead of number, I'm going to replace number with int. And I guess we need to do it. And here, the way you do it is like maybe remove some of the JavaScript. So yeah, this is almost perfect, but in C the types are put before the variable, which apparently is wrong. So which is why in new languages they will have it this way. So let's just call this clamp1, and I guess we need like a clamp2 that will do this. So our expectation is that this one is less efficient than this one. So let's see if we can get this code to compile. So I guess we can just maybe have int x equals clamp. Try clamp1 between 0 and 10, and we're gonna clamp 5. And then int x2 is going to be clamp2. 0 and 10, maybe 5. And here we can just print the values for x1 and x2. Maybe line break also. So maybe this program is correct, I don't know, but we can ask the compiler what it thinks about it. So let's try ask the compiler. Let's try maybe this. Well, no, it doesn't like it, so I guess maybe this. Nope, no, not liking it. And now we have problem. I guess maybe this equal sign here is a problem. Yeah, that looks a lot better. Oh yes, and they want semicolons. The attack of the unexpected semicolon. Yeah, everywhere. And we're using x1 and x2, so I guess here maybe this. Well, it compiles, so I guess that's hope for me. And if I run it, it seems to work. But how can we know that the stuff is actually better? So Oh, somebody's writing to me. Let's see. Max minus, yeah. Yes, it is better. So now let's see if we can figure out how many cycles each one of these things is within. So let's try, there is an online C2 assembly compiler that it will show us, right? So apparently this website, which is it's been going on for a long time. It has this feature where you can try multiple C compilers and you can look at the generated output. So very useful website. And okay, so let's try. Here you can see you have some code in the left and some assembly on the right. So very exciting stuff. So let's try putting the first function, this one, and here we go. So let's do this copy paste, and now here, so there was some assembly output. So apparently, so the way this assembly is generated is that in order to generate all this code, then we have some labels. So the labels are usually like the if statements, right? So CMP means compare. So that you compare something like if, like for example here, you compare EAX with this other variable here, which is relative to this pointer, some 8 bytes like before, 8 bits before. So if this comparison and jump greater means go, if this is true, if it's greater, then go to this place. And then if this doesn't happen, then you put this value here and then you jump to this other. So this is like, if this is true, like if this comparison, well, if it's greater, then this is gonna jump here. And if it's not greater, it's gonna jump there. So we can see we have like a bunch of instructions here, and then 1, 2, 3, 4 labels, and a bunch of like assembly code. Now let's try remove this kind of code. Okay. So we have generated the code, and here you can see this other code. It's a lot shorter, and it has a lot less instructions. So I think that's interesting, because that means that it's possible to know, given two different pieces of code, which code is going to generate the most instructions or the least amount of instructions. So it's also possible that when you're generating these things, like the compiler just eliminates all this code away, right? So for example, somebody can write like for int x equals 0, x less than 10, x plus plus, and then we have some code here, like for example, say int d equals 0, and then here you can have some d plus plus. So this kind of code can happen. Oh, computer failing. Okay, that's good. So what can happen is that the compiler is like, he realizes that this code is irrelevant. Oh goodness. So anyway, oh boy, cannot hang up the call. Well, that's unfortunate. Let's just answer this guys, I guess. Sorry, life gets in the way of the videos. And the computer is slow. Sorry about that. Right. So anyway, you can write some code here, and it's possible that the compiler realizes that all this code is irrelevant, and it's possible for the compiler to be like, actually, I can optimize all these ideas away. And usually on these online websites, these optimizations are removed so that you can see the assembly for educational purposes. So in this example, it's like we write some code here, and then the compiler generates this. However, if you change the settings of the compiler, it is also possible to increase the optimization levels. So you can have GCC optimize, I guess. You can have some settings where you tell it minus -0.1, minus -0.2, and something like that, minus -0.0. So what that means is that it's possible to tell the compiler, well, do your best to optimize all my stupid code away so that it's as fast as possible, right? So here, if we give it this compiler thing, now here, the compiler is doing the following. It's saying, look, you're creating a variable, you're doing this for loop, and then finally you return 0. In order to return 0, we don't really need any of this stuff, so I'm just gonna eliminate it from the program, right? So this is why I had my doubts as to whether or not this code here was actually more efficient than this code here, because the logic, when you're looking at this code, your logic might tell you, well, the compiler will optimize all this stuff away. Or maybe not, or maybe it will, so it's not clear to me, right? So if we try, for example, putting this code here, and then we try putting this code, but we tell the compiler you should eliminate it. So here, as you can see, the O3 compiler is actually having a very short function, right? Whereas the version without it, without this thing here, as you can see, it is also very optimized. It's not that, so it is different. And let's see the differences. So this one has like 9 lines of code, and this one has, yes, quite a lot more. But the difference here is like, it's not enough to justify like the change where you will say, oh, I'm going to eliminate this line because it can be more efficient. Because if the compiler is doing its job, then this problem goes away. Now, the mental model of the compiler that we have is like, we have a mental model where compiler is just generating, it's just putting all the code there that we wrote. So if we write the code, the compiler will translate it. But in reality, compilers these days are so advanced and they can take this dumb algorithm that will do all these things and then just convert it into a much more efficient algorithm. It takes a lot less computing cycles. Now, this is the C++ compiler, which has time to do these things before the programs. But it's also possible that the compiler doesn't have time because it's a just-in-time compiler, like a JavaScript function. So it's also possible that the JavaScript code that we're writing, it's compiled away, but it's also possible it is not compiled away, right? So therefore, it's not clear to me which function is better. But at least for the C compiler version, it does look like if we remove this line, amount of assembly generated is less in both the optimized and the non-optimized. So this is the better option. It is simpler, less logic, it has less code, and the amount of assembly we generated is smaller. It remains to be seen if the B8 JavaScript compiler is also doing the same optimization. So I guess we have to research some more, maybe find some tool that kind of does that. So maybe some JavaScript to WebAssembly compiler must be out there. So I will leave that as an exercise for the viewer. Thank you for your attention.